In Swift, errors are any type which conform to the error protocol. Here's an error struct, an example of an error class, and an error enum. You may notice that the error protocol has no properties or methods, and that should make it easy to conform to. The bottom line is you define your own errors the best way you can. They could end up as enum structs or classes. If functions can throw an error, they are marked with the throws keyword. It's placed between the arguments and the return type. When we call a function with throws, we have to use the keyword try. There are 3 ways to use it, and 1 way not to use it. Number 1, if a function returns a value, and we don't care about the detailed information the error can give us, we can turn the failure into an optional using try question mark. Try question mark wraps whatever the function would have returned in an optional. If an error is thrown, the try question mark returns nil. One benefit of this is rapid development, but the downside is we don't get the detailed information that the error might contain. Sometimes, the fact that something did not succeed is really all we need to know. Negative 1. Before we talk about the second way to catch an error, I want to show how not to catch one. Just like force unwrapping an optional with an exclamation point instead of conditionally unwrapping it, we can use the crash operator with try, like so. Some developers use this when they're confident that the function marked with throws can't really throw an error because they've already validated the arguments. Or maybe they're coding too fast to write proper error handling code. So be warned, if the function in fact throws, your app crashes. Therefore, we'll consider try exclamation point to be an anti-pattern. Number 2, we can basically ignore the error and let it sort of rethrow by default, but we have to declare our function as throwing. So the try keyword is placed in between the call to the function and the use of its return value. All we've really done here is pass the buck. Whoever calls the itCanRethrow function will have to handle the error. Sometimes this is the right thing to do, especially if our errors will all be caught somewhere higher up the call stack. So we won't be surprised to see several layers of code which rethrows the errors for maybe complex data analysis or model parsing code. Number 3, the full way to use a throwable function is to wrap our code that needs the try inside a do block and then handle the errors in a catch block. Here, some code tries to serialize a data model into some data. That process could generate an error, but assuming it doesn't, we move on to trying to write it to persistent storage. Realistically, the disk could run out of space, but usually it doesn't. So the normal flow is that it doesn't. If either of these tries throws an error, the code execution skips the rest of the do block, and it goes out to the catch block, where we may need to report our bug to analytics or let the user know that we weren't able to do what they wanted. Now let's talk about catching specific kinds of errors. First, we need to know what kind of errors a function may throw. Unlike Java, Swift doesn't make the type of the error part of the syntax. This means the only way to find the type of error we need to handle is through documentation. We'll cover documentation in full another week. For now, write a comment with a // before the function and tell other developers what errors can be thrown. Swift will consider as many catch blocks as we write, each one with its own requirements for the types of errors considered. The catch syntax is about the most confusing in Swift. It uses patterns like catching a case and a switch. So instead of trying to understand it, I'm just going to give you some templates as a starting point. If you need more, you can consult the Swift ebooks chapter on patterns. The first is to catch any error. This is what we already saw, a hidden variable named error. This catches every error, and it serves as a final catch-all block. If we know we should be getting errors of a particular type, maybe a Cocoa error for instance, then we can use a cast. But since the compiler doesn't know the actual type of the error at compile time, it will require you to provide a last catch block that handles anything. This is a chance to admit you've no idea what's really going on and provide a graceful fail for the application. Graceful fail doesn't mean crash. Back out and provide an apologetic message to the user. I recommend using an enum to represent errors because they allow you to extract the associated values more directly in the catch block. In this example, by creating our own enum error type, we've stored exactly the information we need to communicate to a power user when we can't import their document. We've got a full pattern for each specific enum case we want to handle that extracts the associated value and uses it to construct a helpful error message to the user. We write as many catch blocks as we need, and write each one as specifically or generically as we like. Today we learned that a Swift error is any type which conforms to the error protocol. Functions which can throw errors are marked with the throws keyword and can only be called with try. We learned how to catch errors of different types in 3 different ways. Throws that don't sneak up on the developer. Now that's Swift.